Welcome to The Explainer. Today we're tackling a massive question. Can an AI actually think like a scientist? I mean, can it go beyond just crunching numbers and actually discover the fundamental laws of the universe all on its own? This whole quest really starts with a hero from the history of science, Johannes Kepler. This guy was the ultimate scientific detective. He spent years just staring at tables of data about planets, trying to find the hidden pattern, the secret rules. And the dream for AI researchers has always been, could we build a Kepler in a box? So here's the big question, right? Can we actually build an AI that can have its own Kepler moment? Can you just feed it a stream of raw observations and have it spit out the elegant, simple law that perfectly explains what's going on? To even get started, the AI needs the same thing Kepler had: data, specifically time series data. And that's just a fancy term for a logbook, right? A list of measurements taken over time. It could be the position of a planet, the rhythm of a heartbeat, doesn't matter. It's the raw material of discovery. And the prize we're hoping the AI finds, that's what we call symbolic laws. These are the beautiful, clean, simple equations that just nail it. Like E equals mc squared. They're not just descriptions, they're deep truths about how things work. For decades, this has been the holy grail and a massive brick wall for AI. Because going from messy, noisy data to a perfectly clean equation isn't just about spotting a pattern. It's about reasoning, it's about a kind of insight that has been incredibly difficult to get a machine to do. But, as you've probably guessed, a new player has stepped into the ring. And yeah, I'm talking about large language models, or LLMs, the same kind of tech behind things like GPT-4. So the question is, are they the ones that can finally crack this? And what's so cool here is how different their approach is. See, older AIs were basically expert number crunchers. They were great at finding an equation that fit the data, but they had no real understanding of the bigger picture. LLMs are different. They come packed with context and knowledge so they can reason about the problem more like a human research assistant would. The big hope here is that LLMs can pull this off because they're not starting from scratch. They have this huge well of knowledge to draw from. They can understand if they're looking at a physics problem or a biology problem, and they can actually think through it step by step, almost like they're scribbling in a notebook. Okay, but talk is cheap. You can't just ask an AI if it's a genius. You have to test it. So researchers built the ultimate final exam for any aspiring AI scientist. They called it Symbolic. And this wasn't some easy multiple choice test. No. The whole point of Symbolic was to make it tough, but fair. We're talking real-world problems, real scientific data from physics, from biology, from medicine, the hard stuff. All right, so the first part of the test is all about systems in motion, where everything affects everything else. Think about a predator and prey population. The number of wolves affects the number of rabbits, and vice versa. The AI's job is to find the set of equations that describes that complex dance. Then they completely switch gears. The next test is about systems that are just on or off, 1 or 0. This is like trying to figure out the wiring diagram of a cell, finding the simple, logical if-then rules that describe how our genes switch each other on and off. And for the final challenge, maybe the hardest of all, can the AI figure out cause and effect? Just by watching something happen, can it untangle that messy web and tell you who's actually pulling the strings and who's just reacting? So, the big moments. After putting these AIs through this absolute gauntlet of a test, how did they do? Well, the results were fascinating, and honestly, a little weird. Okay, so check this out. It was a totally split decision. The big, powerful LLMs were amazing at finding those complex equations and mapping out cause and effect. They blew the older methods away, but they completely choked on the simple on or off logic problems. That's where the old school AIs were still the champions. So why did the super smart LLMs totally bomb the logic test? Well, it comes down to this. Logic is brutal. With the other problems, you can find an equation that's kinda right and then just fudge the numbers until it fits. But with pure logic, there's no close enough. You're either 100% right or you're 100% wrong. But here's the real kicker, the reality check for everyone. When the researchers gave the AIs problems that were totally new, things they'd never seen before, the performance of every single model took a nosedive. And that tells us that true generalization, thinking like a real scientist who can apply knowledge to a brand new problem, is still a huge, huge challenge. So what does all this mean for the future?
Well, these results actually point to a really cool new way of thinking about AI and science, and they might even flip some old scientific ideas on their head.
It makes you question something that's like a fundamental rule in science. Is the simplest answer always the best one? Occam's razor. It's this idea that scientists have used for centuries to guide them. But does it work for AI?
You'd think so, right? But what the researchers found was kind of shocking. Sometimes the AI would come up with a more complicated answer, but because that complex answer fit the scientific context better, it actually did a better job of predicting things on new data. So simpler isn't always smarter. And this led to a real aha moment. What if you stopped pitting these AIs against each other and made them work together? So they tried this hybrid approach. You use the LLM as the creative predictor to come up with some smart starting points. Then you let the traditional AI do what it does best, brute force refinement. And finally, you bring the LLM back in as a judge to see if the final answer actually makes any scientific sense. And did it work? Oh yeah, the results were just wow. This AI team-up scored almost 90% on one of the hardest tasks. That's a gigantic leap over what either AI could do by itself. It really proves that when you combine these different kinds of intelligence, you get something way more powerful. And that really brings us to the final mind-bending thought here. We might be on the edge of a totally new era of science. One where AI isn't just a fancy calculator, but a genuine creative partner. An AI scientist working with human scientists pushing the boundaries of what we know. The question isn't really if AI will discover the laws of nature anymore. The question is, which one will it discover next?